Okay, so this is what you need to know if you want to graph the derivative function if you're only given the graph of the original function f of x. So the maximum minimum points on f of x are going to be the zeros on f prime of x, because the maximum or minimum point is where the horizontal tangent is equal to 0, which is nothing but the slope. So if f prime of x equals 0, all that means is y equals 0, which is a 0 on the f prime of x graph. And then next, the intervals where f of x is increasing or decreasing translate to if f prime of x is positive or negative, because if the slope is positive and f prime of x is a slope, then it must be above the x-axis on the f prime of x graph. And same thing with if the function is decreasing, then it will be negative in the f prime of x graph, because if the slope is going down, which is negative, then the f prime of x graph, which also shows a slope, will also be negative. And lastly, the point of inflection for f of x gives you the maximum minimum point on f prime of x, because the point of inflection is where the concavity changes on the original graph, and where the concavity changes is where f double prime of x equals 0. And that means the slope for the derivative graph is also going to be 0, which means that it's going to be a maximum or minimum on the derivative graph. Okay, so this is our graph of f of x, and here we don't have any equation or any values of the points. We just have a sketch of the graph with the important points marked on it. Okay, so the first thing we're going to do is see the maximum minimum points for f of x. So here we see that there's a minimum, which indicates that the slope at this point equals 0, because the function is not increasing or decreasing, so the slope is 0. And if the slope is 0, then on the f prime of x graph, which describes the slope, must be 0. So we can see right here, we can draw a point on the x-axis, meaning that the slope is 0 here. Okay? And the second one here we have is a maximum point. And again, the slope is 0 because there's a horizontal tangent line at that point. So we can draw another one right here. Okay, so the next thing we can do is look at the points of inflection for this graph. So we can see that there's a point of inflection around here where the concavity goes from up to down. And we also see that the function is increasing at this interval. So since it's increasing here, we can put the point a little bit above the x-axis, and it's going to be above because the slope is increasing here, which means it's positive. So we can put it anywhere around here or something. Now, the next point of inflection we see is over here, where the concavity goes from down to going up. And since the function is decreasing here, we can put the point of inflection, or this point, below the x-axis because the slope is negative. And after this, we have another minimum here, which we can put over here. And now we have these points which we can just trace. So we can start from the right end, and you see that the function just keeps increasing over here. So we can start over here, going from up, and now we just sketch it. Okay, and now we have our derivative graph, just a sketch of what it would look like. And as we can see, wherever the actual function is increasing, from here to around here, the f prime of x graph is also positive. And wherever the function is decreasing, which is from here to around here, or to here, we also see that the function is negative. And then also here, we see where f of x is increasing, the derivative graph is also positive. So we can see that this is relatively a good sketch of what the derivative graph would look like from the original graph. Okay, so this is the next graph we have, and once again, this is the f of x graph, and this is the f prime of x graph we have. So let's first find the max and min points again. So here is a maximum point. So what we're going to do is put a 0 on the f prime of x graph because it indicates a horizontal tangent line. And once again, here we have a minimum point, and this is right about around the origin. So we're just going to put a 0 on the origin here. And the last one we have is a maximum point on right around this point right here. So we're going to put a 0 there. And now let's look at the points of concavity. So here we see a point of concavity. And since the function is decreasing over here, we're going to put this somewhere below the x-axis. So we can put it right around there. And the next point of inflection we have is around here. So also, since this function is increasing over here at the point of inflection, we're going to put it a little bit above the x-axis. And again, now we have a little sketch of what our graph is going to look like. And so let's just sketch it starting from the right. Okay, so this is another sketch of our derivative graph. And as you can see, from the f of x graph where it's increasing from basically negative infinity to this point, the graph is also positive. And then from here to this maximum point, the graph is increasing, which is also shown here. And then from here to infinity, the graph is decreasing, which is also why the derivative graph is negative. And also here, from this point to 0, the graph is decreasing, which is why the derivative graph is negative, below the x-axis. And also, it's not very smooth. My sketch isn't really that great, but this gives you a little idea of where the maximum and minimum points are, and also where the point of inflection is, based on the actual original f of x graph. So this is the final result.